Watch the water leave the bucket. It does not spill over the side, it climbs a tube up and over the rim, then pours out somewhere below, moving uphill first, then down, with nothing pushing it. No pump, no power, no moving parts at all. Just a bent tube full of water and a little patience. It looks like a trick. It is not. It is one of the oldest quiet machines we own, and gravity runs the whole thing. Here is everything you need. One container of water sitting up high, one length of flexible tube, and a lower place for the water to go. A floor drain, a bucket, a garden bed. You drape the tube over the edge of the upper container. One end rests beneath the surface of the water. The other end hangs down, past the bottom of that first container. That difference in height is the whole secret. Hold on to it because everything else depends on it. A siphon will not start empty. The tube has to be completely full of water first, with no pocket of air trapped inside. People do this two ways. They sink the whole tube until it floods, then cap the ends and set them in place. Or they suck on the low end like a straw until water rounds the bend and begins to fall. The moment one unbroken thread of water spans the high point, the siphon wakes up and takes over by itself. Now look at the tube as two columns of water joined at the top. On the source side, a short column rises from the surface up to the bend. On the outlet side, a long column drops from that same bend all the way down to the open end. It is the same water, in the same tube, but the downside is taller because its end hangs lower than the surface it started from. Two columns, one short, one long, both pulled straight down. Gravity pulls on every drop in both columns at once, but the longer column holds more water, so it simply weighs more. It is a tug-of-war across the bend, and the heavy side wins. The long column slides down and falls out the bottom. As it falls, it cannot leave an empty hole behind it, because the water is one connected chain. So it drags the column behind it, pulling fresh water up the short side and over the top to take its place. Something has to keep feeding that short side, and the air does much of the work. The whole world sits under an ocean of atmosphere, pressing down on the open surface of your upper container. When the falling column lowers the pressure up at the bend, that outside air pushes on the surface and shoves water into the tube. Up the short leg it climbs, around the bend and into the long fall. Gravity pulls from below, the atmosphere presses from above. There is one more quiet force at play. Water molecules cling to each other, a property called cohesion. Inside the narrow tube, the water behaves almost like a soft rope. Pull the bottom end downward and the whole rope follows, even up and over the high point of the bend. That is why the chain does not just snap apart at the top. Air pushing from outside, water holding hands on the inside, together they keep the thread unbroken across the climb. Everything depends on a single rule. The outlet must sit below the surface of the source. If the open end is higher than the water you started from, the long column is no longer the heavy one, and the flow simply stops, or even runs backward. Lower the outlet, and the water races out. Raise it until the two ends are level, and the siphon stalls in a perfect silent balance. The bigger the drop between the ends, the faster the water runs. A running siphon keeps going until something breaks the chain. Most often, the upper container drains down to the mouth of the tube, the end gulps a bite of air, and the thread snaps. The flow dies at once. It also stops if the two water levels ever rise and fall to meet, leaving no height left to drop through. And there is a ceiling on height. Near sea level, air pressure can only support a water column about 10 meters tall before it tears apart. Once you see it, you find siphons everywhere. They empty fish tanks without lifting a single heavy bucket. They drain a flooded basement down toward a lower drain. They move fuel and wine from a high barrel to a low one. Your toilet hides one too. The bowl empties through a siphon tucked inside its curved porcelain throat. The Romans even carried water across valleys this way, letting pressure pull it down one hillside and push it up the next. Now the honest part. Scientists still argue over which force matters most, the push of the air or the pull of cohesion. In ordinary tap water, both are at work, and which one leads depends on the exact setup. With special, carefully prepared liquids, a siphon can even run inside a vacuum, where no air pushes at all. So picture air pressure and cohesion as partners, not rivals. The everyday version you build with a garden hose quietly uses both at once. So here is the whole chain, start to finish. Drape a tube over the edge with its outlet hanging lower than the source. Fill it completely, leaving no air trapped inside. Now read it as two columns, a short rise and a long fall. The long, heavier column drops, and because the water is one connected rope, it drags the short side up and over the bend. Outside air presses the surface to feed it. It runs until air sneaks in, or the levels match. Gravity all along did the work. No motor, no moving parts, no power cord anywhere in sight. Just a tube, two water levels, and the steady pull of the planet underneath it all. The next time water seems to climb uphill on its own, you will know the secret. It never once broke a single rule. It only borrowed gravity for a moment and then gave it right back. Thanks for watching The Cutaway. We will slice open something new very soon.